This video looks at finding the confidence interval when we do not have a known population standard deviation and we have a small sample. To do that, we're going to look at example 2. A patient complains about a dentist fees. She surveys 20 patients and finds a mean of $44.80 with a standard deviation of $3.53. Find the 95% confidence interval for the population mean. All right, now, in order to do this, first thing you need to do is pick which formula. And we would prefer the Z version of the formula, but we don't know the population standard deviation, and we also don't have a large sample. We have a sample of only 20. So in order to pick the right formula, we have to not choose the Z version. We have to resort to this T version. Now, you'll notice there's a lot of similarities between this and the original formula. And as we start walking through this, I'll talk more about them. So we have this basic formula, and the layout is essentially the same. Instead of sigma, we have S. And now if you think about it, S is the sample standard deviation. So it's the same concept in the same spot. It's simply a different notation. The other thing is, instead of Z of alpha over 2, we have T of alpha over 2. And we'll talk about that in more detail when we get down here. Now, to do this, X over bar is still the sample mean. So that's the 4480. The S is the sample standard deviation, 353. Sample size is 20. So what that leaves us with then is this T of alpha over 2. Now, to find the T of alpha over 2, we need to know the confidence interval, and we need to know this DF here. DF is degrees of freedom, and it is equal to the sample size, n minus 1. So, in your book, either on the insert or in the back, you should have a table for the T distribution. And the easiest way to do this, there are columns for the confidence interval. The 95% confidence interval is the center of the 5 data columns. And we need to come down to the row will be the degrees of freedom, in this case 19. And if you come down that row, you'll see 2.093. It's also possible to do with Excel, as you'll see in the notes. And so that 2.093 is the number that goes in here. Now what you'll notice is that 2.093 is larger than 1.96. And that's the thing with the T. We need to have a bigger number there. We end up with a wider range because we have a smaller sample. All right, so we take the 2.093 times 3.53 divided by the square root of 20. Grab my calculator. 2.093 times 3.53 divided by 20 square root is equal to 1.65207. We want to go to 2 decimal places to match what we had in our mean and standard deviation. So we round that to 1.65. And then once again, we can either do the arithmetic or we can make it mu equals 4480 plus or minus 1.65.